Now we have to discuss about some properties of charges. Properties of charge. In that we already discussed about that. What unlike charges attract each other and like charges repel each other. So this is the first point. Means positive positive repel, positive negative attract. So that is the first point. And the second one is the smallest possible charge. Smallest possible charge is charge of electron. What is the smallest possible charge? The smallest possible charge is charge of electron. And here we have two types of charges. One is positive charge and another one is negative charge. The charge of proton or electron is nothing but 1.6 into 10 to the power of minus 19 coulombs. So here you have to remember one point, that is SI unit of charge is what? Coulomb. And we know that mass of proton. What is the mass of proton? It is 1.67 into 10 to the power of minus 27 kilograms. And mass of electron equals to 9.1 into 10 to the power of minus 31 kilograms. And next one is charge is quantized. So what is the meaning of this quantization of charge? Quantization means if we want to transfer charge from one body to another body, then the charge is flowing from one body to another body in the form of number of electrons. Means here one body is there, here one body is there. Then it is possible to transfer one electron or two electrons or three electrons or four electrons from one body to another body. But it is not possible to transfer half of electron or one third of electron or 2e by 3. Means this type of transformation of charge from one body to another body is not possible. If we want to transfer electrons from one body to another body, then it is the only way. That is, we can send electrons integral multiple of electron. Means one electron or two electrons or three electrons. That is, total charge is quantized. Means it can be written as Q equals to plus or minus Ne, where N equals to 1, 2, 3, so on. So this is known as quantization of charge. Quantization means nothing but if we want to transfer charge, then it is only possible in multiples of electron. Means one electron, two electron, three electron or four electron. But it is not possible to transfer half of electron or one third of electron. That property is known as a quantization of charge. And the next one is, for an isolated system, the charge is conserved. Conserved means the charge neither can be created nor destroyed. Okay. Conservation means, for example, if one isolated system is there, then here three particles are there, A, B, C. So the charge on A is 4 coulombs, charge on B is 3 coulombs, and charge on C is minus 2 coulombs. Now, I made some modifications in this body and I obtained the same system A, B, C. So, due to the modifications what I made in this body, I observe the charge on body A is 3 coulombs, charge on body B is minus 1 coulomb, and what is the charge on C? Now, we want to calculate the charge on C. So how can we calculate that? We know that for an isolated system, the charge is constant. Means 4 coulombs plus 3 coulombs minus 2 coulombs equals to 3 coulombs minus 1 coulomb plus x. Means here 7 minus 2 equals to 3 minus 1 means 2 plus x. It is 5 equals to 2 plus x. Then x equals to how much? 3 coulombs. Means what modifications we made, but the total charge remains constant. This is known as conservation of charge. Means the charge in an isolated system is conserved, means constant. Okay. So these are the important properties of charge. And one more is the charge is invariant. Charge is invariant means if the charge is at rest or the charge is in motion, whatever may be the position, whatever may be the situation or condition of the charge, the total charge is constant. Means unlike mass, if the mass is at rest or mass is moving comparable velocity of light, then we know that the mass is changes. So we have to attempt that in special theory of relativity. The mass of the body is rest mass of the body upon 1 minus b square by c square. Means from this expression we know that the mass of the body is changes in motion, but here the charge is invariant means either it is rest or it is in motion. The total charge is constant. There is no change in charge. Okay, due to its position. That's why the charge is invariant. Now, one more property is the interaction between two charges is independent of presence or absence of another charge. The interaction between two charges is independent of presence or absence of another charge. So, in order to understand that, here we have one charge Q1 and one charge Q2. The interaction between these two charges, now I keep here one more charge Q3, means whatever may be the force between these two charges is independent of the presence or absence of that third charge. Okay, this is also one of the property of the charge, that is the interaction between two charges is independent of presence or absence of the another charge. Okay, so these are the properties of charges. Once again, we will recapitulate. What is first one? Charges are at two types. One is positive charge, negative charge. Like charges repel each other, unlike charges attract each other. And we already see what is the charge of electron, mass of electron, and mass of proton. And the next one is charge is quantized, equals to plus or minus Ne. If you want to transfer charge, then it is possible only in the integral multiple of electron. And one more is the smallest possible charge is charge of electron. And next one, the charge is conserved, means for an isolated system the total charge remains constant. And next, the charge is invariant, means the magnitude of charge does not depend on the condition, means either it is at rest or it is in motion. So there is no change in the magnitude of charge. So that's why the charge is invariant. Okay. And what is next one? The interaction between two charges is independent of the presence or absence of the another charge. So these are the important properties regarding charge.